So everything is okay. I will ask someone. Harshavardhan Patil. Harshavardhan Patil. Please reply. Harshavardhan. Am I audible to Uday? Can you reply?
Yes, sir. Yes, sir. Yes, sir.
Screen सब सही दिख रही है. Okay. So shall we start? Okay. So I have drawn this for the earlier batch. I will not draw that again. Just open the. Okay. So this is our part. So this is to be manufactured, and we have to just generate the part program of this profile. So there will be two machining, that is space milling and second one is space milling area, that is profile milling of this. Okay, so this is already done. So I will delete this. So I will delete this and recreate it again. This also I will delete. Okay, so now I will save it. So it will be okay. So first, what you have to do, you have to just draw this. I will upload this also. Okay, so just sketch this, then model it. Okay, as per the drawing, and this radius is, I think, is not given. You can, no, it is given. R10 one dimension. Okay, 5 all dimension. Okay, all dimensions are okay. So you have to first model this part, and then after that you have to suppose we are in the modeling. Okay, you have model this part. Okay, after that you have to go to start. In that start, you have to select manufacturing. You have to select manufacturing. So in this manufacturing, okay, so in this manufacturing, there various methods are there of machining. So it will be mill planer, milling operation. As per the operation, milling will be there. Then in milling, there will be a milling planer will be there. Then next one, contour milling there. Okay, and it's some types. Okay, then drillings are there. Drilling is there. Turning operation. Okay, so all the types are there. So first, when you just move the model into this manufacturing workbench, then you have to, there is a three views we are going to use, this program view, machine view, and the geometrical view. Okay, so first to go to geometric view. So in this machine coordinate system, you have to click it, and then in this machine coordinate system you have to link this. There will be if you just transfer your model into this, imported your model into this manufacturing, it is not. Okay, so you have to click this link reference coordinate system to machine coordinate system, means workpiece 0 and machine 0 where to make it. Okay, just check this box. Okay, and select OK. Then after this, go to this workpiece. Okay, so double click on this. So I will remove this. Okay, I will remove this because it is already given. Okay. Okay, now before this, when you move from this, okay, I will close this. Then you have to double click on this workpiece. First, you have to link your reference coordinate to machine coordinate system in this. Okay, in this you have to link this first, and second, double click on this workpiece and then you have to give. I think it's showing saved, so that's why it's doing that. Okay. Okay, now it's get deactivated. Okay, so when you open this min geometry, you will see this specify part. The torch is not on; it is deactivated, and then specify blank is not on. Okay, so this all three are inactive. So to specify your geometry, first you have to specify the part. So what is the geometry is there? So you have to specify that. Okay, so you just click on this, select the part geometry. In this geometry, you have to select all all the body of your geometry. So there may filter methods also there. If you only want the facets of the bodies or faces or the curves of the of this circle is of the model, you can select that. So I will select the bodies because I want entire geometry to be specified to the software. So that select all and select OK. Now you can see over here this torch is gets activated. So you have specified the part of your geometry. Next, you have to specify the blank. Blank means the raw material before machining. It will be a simple block. Okay, and then from that block you have to create this model. Okay, you can able to see this profile over here, but in actual you have to specify the software that it has this block, this dimension. Okay, so for that, just click over this specify blank. So in this specify blank, there are various options are there. So if your a block or your workpiece, whichever you want, a machine is a rectangle or square, then you can use this auto block so that it gets the shape of that directly. Okay, if you have the model circular one, or circular bed is there or table is there to be machined, then this auto block will not be useful because it will take the rectangle shape only. Okay, so at that time you have to use this geometry, and then you have to select that body, and it will create that as per the blank here. Suppose there is circular part is there, so it will take a circular block, circular or a circular bar of that. Okay, so in this case you can use this auto block. Okay, so as it is 27, so our blank piece we are considering it is a 30 mm thickness, so we have to increase that 3 mm over ZM axis. You can see over here ZM axis is there. So this is your working axis of your machine. So select that 3 mm more. So this line will get lifted. You can see. Okay, as it's small value. If I increase this 30, you can see this. It goes up in the upward direction. 30. Okay. So I have just want 3 mm from that surface of this model, just 3 mm above. So we are considering that this is a block, a simple rectangular block of 95 by 100, and its thickness is 30 mm. Okay, after machining it becomes 27. So in that way, you have to select ZM 3M and select OK. So now this specify blank gets activated. Okay, so specify is used for whether geometry. You can check use this or select all, or you can just no need for this specify check. Okay, yeah, if you keep this as by checking it or not checking it, it will not affect the machining. Okay, now we have to specify the material of your workpiece. Suppose it is a aluminum material. Okay, aluminum, or we will take for this batch as this is a tool steel, or it's a, okay, it's a HSM copper. Okay, copper material we will take. Okay, and select OK. Okay. Just randomly I pick the material. Now for this you have to import the operation. Okay, how to import it? Just right click on this workpiece, right click on this workpiece, then go to insert operation. Okay, so you can create from here also, create option directly, options are there, create tool, geometry and all here directly on this ribbon. There are the tools are available, but the right way is that right click, because we have to link this workpiece. It should be linked with the machine coordinate system, then workpiece. It should be work under workpiece, so that the programming will be interlinked with each other. Okay, so for that, right click on workpiece, then go to insert operation. In this operation, you can see over here, mill planer is there, mill contour. Okay, mill planer means facing operation. It includes subtypes facing, face milling area will be there, profile milling and all. All this type of operations will be here. In mill contour, if it's die cavity, you have to mill. Multi-axis is more than 3 axis are there. 4 axis, 5 axis machine, you can use this. Okay, drilling for drilling also. Okay, hole making for boring, then turning, when we use a turning sensor, we can use this. Wire reading programming can also be possible by using this software. Then probing of the CMM, we can use that. Okay, so we'll bring first mill planer. So in main planer, there are subtypes, operation subtypes are there. So face milling area is there, face milling simple, the next face milling manual. Okay. So if a wall only you have to finish the floor, if you have finished the you have to finish only the walls, then you can use this. Okay. If thread milling is there. Okay. In this way, subtypes are also available in this mill planer. So we have to perform two operations, that is milling. Then after we have to perform an operation that is the profile milling or the face milling area. We can say. Okay. So first we use this face milling. Okay, because we have to remove the material, excess of material from the blank of about 3 mm thickness. Okay, so for that use face milling. Program will be NC program. Okay, then in the new versions, you can save your part program in a numeric as per the as per you have the machine. Suppose it is like a Siemens machine is there, then you can import or extrude that part program from this software, and directly you can put in the machine, so we can take that reference of that model, and it will machine that part. Okay, so in from 11 and 12, that's an option to save that part program. So in this, if you use this program directly, it will not work. You have to just change the some codes from that, so that will be suitable for your cement control. Okay, so this tool is directly here, so I will use none. I will show you which tool we are going to use. Then geometry, it should be workpiece, because we are creating this operation under workpiece. Okay. Method, you can select mill finish or mill rough. Okay. The mill rough, if you select this, it will select the floor. Floor of after machining will be there. Some material will be there. So I will use this method only, and I will define the how much it should be machined. Okay, face milling. Okay, name of this uh, program will be a face milling one of this operation. Then here you can see the specify part, because we have given earlier in the workpiece only, and that is we have specified the geometry of the part. We have specified the check. Okay, we have specified this this also. We have specified the blank, and in this the blank is there. Okay, so we have given that, so no need to again give it, because that's why it gets activated. This display gets activated. Now you have to specify the boundaries where your thing should stop. Okay, I will select that. So my machine should stop over this profile, means this up to this surface, that is 300. it should stop over here. So I will select surface. Okay. After this, boundaries. If a wall boundaries, you have to we have to means edges are there. If you want to give that means the boundaries should be machined over there. Then you can use that specific check boundaries. No need in this. We are just machining all the parts of this top surface. So now we have to specify the tool. For specifying the tool, go to create new. In this, various tool types are there because we are in main planner, so it's showing this sub tool subtypes in the milling only, that is used in the milling operation for this mill planer operation. Okay, so T slot type and the barrel type and threading, face milling, ball mill, and the end milling cutter. So I'm using the face milling cutter because the facing operation is just the face milling cutter I will use. You can retrieve the tools from the tree also, but in the milling you can take from this end mill cutter, barrel, and but the tool you are going to specify, if it is of different diameter, then there will be error in this machine. It will the machine move. So you have to give the cutter some radius compensation in that also. So instead of that, you can uh, directly use new and index face mill, and whatever the dimensions are there of your face milling cutter, you can use this. I will use the 30 diameter. Suppose I have a 30 diameter face milling cutter. Okay, and then its lower radius is this much, and then length is 50. Okay, then this 50, that is sufficient because uh, you have to just check that flute length should be more than the depth. Okay, more than the depth of your cutting. It is 3 mm, so 25 mm is sufficient and for it. And the flutes are 8 used, means 8 inserts are used for machining of this face milling operation. Okay, so these are the by default values. If you have some other values of your tool, then you can change that tools as per the terminology given over here. Okay, then you have to specify the material of your tool. In this, suppose I will using carbide of uncoated type. Okay, and I pick that material. So that is okay. Now then you have to use the number. Suppose this is the tool number 1. Okay, so that at the time of the part program when we generate it, so this will be specified as the tool number 1. Otherwise, it will take 00. Okay, so it should be a tool number 1. Okay, then if you length composition you have to adjust, then you can use here how much. Suppose you use other tool for workpiece 0 reference point system when you give on it. It is of larger length, then you have to adjust that. Okay, and then next, a holder. You can select this holder diameter and also those. So you can use it. Okay, so I'm not using this. You can use that as per the diameter. You have to give this. So I have diameter is 30, so it should be more than that. Okay, so it should be 50, and uh, this length should be in that way. Okay, so by using 40, suppose cannot be smaller than or equal to 0. So it's good that to increase the length. Length should be for 25 or 20, you can say. You can see over here. So this tool holder is here. Taper angle was 6, corner radius 5. Okay. So in this way you can change as per your tool holder. You can give the dimension. So machining control is given whether it is clockwise in direction, rotating clockwise or anti-clockwise. Spindle is rotated as per that. Tracking points means the where you can give the track points over here. Okay, as per the diameter and distance you can give here. This is my stacking point of that is the approaching point towards the worksheet. Okay, so I don't want this. Simulation settings are there. When you want the head mount of this, how much value you have to give that value. It's 3 mm, 5 mm you can take. I not want this folder. I'm just showing you. Okay. So after specifying the tool, your output will be tool number. Adjust. I have not adjusted any lane composition and all. Then cut composition is also not. If this is the length adjust length composition is cutter radius composition, then you can give over here. If there is any offset, you can give over here. Okay. So I'm not want anything. This. Okay. Next tool axis is okay. Normal to the face of that model. And method I have selected method. Now this is a strategy of a pattern. When it's a toolbar generation, so there are various options available over here: Z pattern, zigzag pattern. So and then the mixed pattern is they follow the periphery as per the profile. It can follow the part. Part means a rectangular. It is a rectangular part, so it will follow part means a rectangle. It will move. Okay. So for face milling, the most commonly used cut pattern is a zigzag pattern or zig with contour you can use. But at that time, the retraction of the tool is more, so more number of blocks will be generated in this at the time of the post process. So zigzag pattern means that in that it will go inside. Okay, it will cut that depth and then it will move without retracting. After the completion of cut, it will get retracted. So there is no rapid traverse is also less, and time required per month is also less compared to the zig pattern. So I will show that how what is the difference between zig and zigzag pattern after completion of this other values. The next one is a step over. So in the step over means suppose one cut has been completed cutter, and then we have to move the distance as per the flat diameter. Uh, that percentage is given over here. That is the percentage of flat diameter. You can change that directly constant, suppose constant value. Then it will move as per the 12 mm, 12.7 inch randomly. So I can change that to 12 mm. Okay, constant value it will move. The step 4 will be 12 mm. If you scallop, so this is for wall scallop height means it is for wall machining is there. Suppose you have to mill the wall. At that time, this scallop height is used. Okay, and variable average as per the average, what will be the maximum you can prefer and what will be the minimum? What is the blind distance you have? You have to give this. Okay, so I will pick the percentage. So percentage 50%. Suppose I will take 50%. So the step over will be 15 mm. As the diameter of the cutter is 30 mm, so it step over means after cutting of one it will cut. It will have to move towards left or right. Then at that time it will move 15 mm, and then it will start cutting. Okay, so I will use that at 50. Okay, for face milling it is okay. Then blind distance. So the cutter, how much distance it should start. So blind distance is 3 mm. That's okay. Then depth of cut, as it is there, I will use one mm. So it will cut three times the depth. So there will be three depth will be there for finishing the face milling. So it will take three depth of cut. Okay. And the final flow stock, I don't require any flow to be remain for the machining. So I will use 0. If you want some finishing operation, you have to add some finishing operation in this. You can use a zero point 0.5 or 1 mm for the final flow stock. Okay. Then next one is cutting parameters. So cutting parameters, I will check just whether I'm okay. Now in the cutting parameters, so cutting parameters are related to the cutting strategies and all the parameters involved at what gets rotated and it moves from out to in. So while cutting, okay, so you can see the direction of the inserts in this way. So what should be the angle? Time of the next cutting of this face filling area. They this is the merge distance. If you want to merge it as per the tool diameter, you can merge it 50%. This is the default values. Okay, so how much the blank should be overhang with respect to the tool percentage is that 100% it should be overhang. It should be remain. There should be no any contact between the blank and the tool. The next one, stock, as they have not selected, said the depth after cutting will is 0. So there should be no flow stock we have mentioned. So the part stock is also 0, wall stock, this all will be 0. Okay. So intolerance and tolerance is given. So it is the default value 0.03 you can take or between 0.05. So 0.05 is the maximum you can take the tolerance. Okay, intolerance and outtolerance. Then corners. So the corner, suppose this type of cutting and profile is there, and if I want, when there is a edge, make a round around this edge, then you can use this. If you want a screen, so in this way it will take a chamfer type tool path will be the chamfer type. Then extended in this for the profile, it will move in that direction. The tool will move. Okay, I will use round around. So it is not related because the staging operation is there. So this will not affect the machining. Okay, smoothing go. You can add all passes. Okay, you can get a smoothing effect. So this is related to the tool percentage. How much step over limit is there? Okay, so I taken 50%. Directly take the 50% of the tool. Okay, so I will not use this none connections. In connections, this is the strategy regarding the cutting order. So the software will decide as per you defined it. Optimize means region sequence. Suppose this type of model is there, you are going to machine that is of thick pocket. Then it will move into it. First it will machine this, then this, in this way. If you use this standard type, then it will move in this zigzag pattern. It will machine first this pocket, then goes to this second, then third and fourth. Then for the start point, so where you have given the starting of your tool position, it will follow that point, goes to in this way. Okay. If you use a follow free drill, so it will drill first to the depth, and then it will machine this first and second, third, fourth, etc. So optimize region sequence is more uh, means create less blocks, part program blocks. So it will the software will decide what is the optimum tool generation will be there. So it will take less number of blocks. So that is this cutting regions. Then across voids, so there's a motion type. Uh, so it will follow. In this case, you can see it goes pushes over here, then it gets machine here, then again it gets lifted and this way. So it leaves this pocket over here. Yeah. This is the follow motion type. Then in cut type, you can see in this it goes directly cutting. It will not lift upward in that way. And traverse, it directly traverse in the direction of cutting. Okay, and minimum traverse distance you have to define that. Okay, so I will use follow and minimize the number of engages. So if you check this, then it will not lift much more. Okay, so I will minimize the number of engage. The engage and disengages will be less. Hmm. Then containment, if you use the tool holder, then it will this tool holder will be there. Okay, so related to tool holder, I don't want select okay. So after this cutting parameters, there are non-cutting parameters. So you'll see that non-cutting parameters means there will be no cutting operation will perform, but these parameters will be considered at a time of machining. Okay, so you see over here, this is approaching the engage type of the cutter is a helical type. Okay, you can see this. If I use this, the ramp on shape means as per shape it will ramp in goes inside the for the machining. Then helical is the circular type, just before it is shown. Plunge means it directly plunge into this pocket. Okay, so I will use helical. That is much easier. As per diameter, 90% of that it will rotate in. Angle is given. So this is default value as per I have selected the tool diameter. Okay, so it is taken that. Okay. Then retract, I will keep as it gets engaged, uh, it should be retracted in that way only. You can change that also by linear, by arc method and all. Retracting position, then you have to give the angle and turning. So same as you engage the tool should be retracting in that way. Okay. Then if you want the start and the drill points from the center, from the corner, then it will be change as per that. So midpoint will be there. Corner point, if you want to start corner, you can select corner. Okay, I will use corner. Okay. Then again, effective distance is given here as per the diameter of the printer. Then transfers and rapid motion. So there should be clearance. So this no need to change it. Okay. So in this previous plane, as per the previous plane, direct, as per directly it will transfer. So I will use the clearance. There should be clearance between the workpiece and the tool. Transfer using is engage and retracting type. It will refer that engaging and retracting. Okay, and there should be clearance. Okay, so I don't change any values over here. Method over here. These are the avoidance. Avoidance are used for suppose there are clamps used over here for clamping this workpiece on the machine, and then you have to specify which where the clamp actually is. So you can select this specify. So suppose I specify that at my suppose I click here. Yes. Then I specify that at this point there is a clamp. How much distance it has from x the y direction you can give it. Okay, in that way. Okay, so this avoidance is used for. I will not use here because there is no any C clamps and all. It is not there. The starting point, returning point you can select. This is for the avoidance purpose. The starting point of your tool, ending point of your tool you can use here or specify by the values. Okay, after specifying, you can click over here. Okay, click here and then click over here. So it will specify this tool will start from this point and what will be the return point or home point, home position, G28. Okay, so you can use that. So this is our button. In more, if there is any collision is there, so you have to check this collision check. Okay, so as there is no clamp, so it will not show any collision check. Okay, that is in process workpiece collision, IPW is there. So that also you have to make sure that it is checked. Okay, so that the program will stop over there. Now next one is a feed and space. Feed and space, in this you have to specify the spindle speed. So suppose I am for this machining purpose I am using 600 RPM. Okay, it just check on this spindle speed, so it will calculate your material and the number of flutes of that metal, and it will give you the feed per tooth and the spindle speed. Just check over this, so it gives you surface feed and the feed per tooth. Okay, now if you want to change this value, you can change it. It is a feed rate value 100. I will take mm per minute. Mm per revolution also you can take. You have to change that value. Select OK. Next, these are the related to feed and speed. So next one is the machine control. So in this only that is the start path eventual. So this is not required much. Is as per default you can take. Okay, linear only. So as per default, you don't require this motion output. Okay. So in program, we have selected that MC program not required. Edit display means the color combination of your retracting, step over, and other operations, machining operation, rapid traverse. Okay, all that will be here. You can see over here. If I click over this part display colors, so rapid for rapid is using red color. If you want to change it, you can change it. Just click over that and then you can change the color. So these are the rapid is there, approaching of tool, engaging of tool in yellow color, first cut, okay, then step over is green color, and cutting operation, and traverse blue color, okay. There will be dotted one, dotted, that is the traverse, and then retracting, okay, the faint pink color, departure. So you can change that color also. I will choose the repetition is of color, I will change that brown. Cut, I will change this color to cutting is there. So I will use purple color, lavender color, so that there may be difference in the okay. And select OK. So this is the toolpath generation options. If you want a 2D toolpath generation, you can use that. How much frequency 3D, but you're selecting this, it will create more time for creating the toolpath. If the more complex shape is there, then it will take more time because it is related to simulation only display purpose. So I will use this. You can check these two options: 2D how it looks, 3D how it looks. You can check it. Okay. Then here is the path generation options are there. So display cut region. So if you check this, you will display the cut region, cutting region, and pause after display means after one cut, cutting operation is done. After changing any step over, then it will be stopped. The program will be stopped. Path generation will be stopped over it. Then your refresh display, you can check that suppress of what. So this is not required. Click OK here. And now last the action you have to create the tool path. So click on generate. So now you can see over here. You can see. So this is in here dotted red line. That is the this is the retracting or rapid traverse. Rapid traverse. This is the upstream. This is the where we have started. Okay, and it is moving in this RAM. It is selected as a RAM. So I will change that cutting parameters. No, in non-cutting parameter you have to change. Okay, helical. Okay. Where as we taken from the corner, it is directly taken by default RAM plunge side. Okay, just taken from the center, it will be helical type. Okay, so this is after. Then the cutting is in the lavender color, you can see, and this green color is the step one. Green color is the step one, and this pink color is in that is the retracting one. Okay. This brown color you can see over here. This brown color is the departure of tool. Retracting is in finger. Traverse, this traverse is in blue. Okay. Then next one, approach is, this is the approach. Traverse is not there. So as we use the zigzag, so it is not there. Okay. So step 4 is more, so I will change that step 4. So, and I will use 30% step 4, depth of cut 1 mm, and then again generate it. So now the distance will be reduced. Okay, distance. You can see step 4 will be reduced. Okay, a more finer machine will be there. But it's taking more time. The number of blocks will be increased if I reduce this step 4. Number of blocks will be increased. Okay. But it will give you more surface finish compared to the first one. Okay. So total there is a 3. So I will use 40. Okay. Now generate. Okay. So that is okay. Now we have to verify in the next step. Yes, after completion of this. You can directly take, you have to save the block. Then what is the strategy is that instead of depth of cut 1 mm, you can directly take 3 mm. So it will take in the single pass. It will complete in the single case. It will complete this in a single pass. So less number of blocks required. See that only in a single it will complete that machine. So I will take this. So what is difference between the cut pattern? I will show you that. If I use this jig pattern, then will be difference with the, in this you can see that when the cutter gets engaged, complete the machine in the exact way, exact fashion. It goes here, again step 4 in here, again a step 4 there. Okay. If I use this jig pattern, then you can see, and there is only one ending and disengaging point, and rapid curve is also there. if I use zig, then what will happen? So you can see retracting is more, then rapid traverse is more, approaching is engaging is more. Okay, and the number blocks also increased. So that is difference in the cutting pattern approach. So this zig pattern is useful in the operation is simple in a single pass is there. There is not much more step overs are there required. And in case where clamps are there, more clamps are there, at that time zig pattern is useful. But mostly it is used when you have to machine a company in a single or in a single cutting moment, the single cutting moment, then you use the zig. If number of sepals are there, then it is not useful this pattern. If you use this for part, then what will be difference you can see. So as per the part is a rectangle, so I think the speed is reduced. That's why it's generating slow. I will increase the speed. After this, I will increase the speed. So as per the part shape, it is creating that shape type toolpath. You can see that. As per the profile shape I have drawn in that model, it is following that profile formation. You can see over here, this. Okay, in this way. So it is much complicated. So it is not required for a face milling operation. Then for periphery, I will increase the speed. In this fashion, is to reduce taking more time. So now you can see. Although periphery I will use. It is also using the same periphery of the profile. If it is a rectangle one, then it will use the rectangle shape of that. Okay. So in this profile, you can see this. So profile is not working over here. Okay. So we have not used this. So zigzag pattern is more suitable for such stage tuning out. Okay. Now we will verify this simulation. Go to verification, and then after this, there is two options. 3D dynamics means we can get in 3D, or 2D dynamics means no material will go over here. Directly it will move as per the path generated. So I will use 3D dynamics. In this, IPW is, that is in process workpiece, for the protection of the collision. So this checks for IPW collision in process at the time of machining. This should be checked. Okay, and I will reduce the speed at the simulation in this way. Phase tuning operation will be carried out. Okay, so today we will see only this operation, and we will continue this session in the next Saturday. And at that time, we will complete that file, and we will see another. If time permits, we will see another example, that is second part, that is cavity milling. So just click on this. So we have verified it. You can see over here. Yes, geometric view. This path is generated, so it's showing green color symbol. A method we are used face filling, work with geometry we have given that method. So now only is that I will not generated the part program. So that's why it's showing over here exclamatory mark. So for that, just go to this workpiece, click on this, and just go to this process, or right click on this and go to post process. Our machine is a 3D mean 3 axis. Say where you want that. I want it should be browse over here, and where you want. Okay, so I have browsed that earlier also. It will show me you have to overwrite and all. So I will change. I will override that. Okay. Then what units you are going to prefer, that is metric unit we are using. And in the newer version, there is a numeric option is there in this, so it will generate it as suitable for the machining. Directly you can put that part programming for machining. So click OK. It will ask you same file is already there, so override that. Okay, now you can see this exclamatory mark is turned to green, and now we'll check the programming is generated or not. So this is our generated program. Okay, we have just generated this. We have used P01 tool, M06 tool change and all. Cutter compensation is, the height compensation is given, so it is H is given over here. Then your clockwise, that direction, anti-clockwise. Okay, so all program is generated. M02, if you want to change this to M30, if your number of job operations are there, then you can change this to M30. Okay, as per the user defined. So this is the facing operation. Uh, Facing operation. After this, you see, and if you move towards this program order view, you can see over here. It requires 12 minutes and 55 seconds to complete this. Okay, which machining is used and all. So this is single operation. So now again we have this part is also remaining for cutting, that will continue in the next session. In machine view, we'll see which type of materials, sorry, which type of tools you are used. So these are used for the last batch, so it's showing that. Okay, so for our batch we are used this, so it's showing that for by using this face mill one we have performed this. As I have deleted that, so it's not showing me over here. Okay, so for this operation we have to use this. Machining one workpiece, tool number is 1. For that batch I use that tool number as 12, and for second 2. Okay, so for one we will use 1 and 5. Okay, as per the tool are included in the tool magazine, we have to specify that number. Okay, so that's all for today. Any questions are there, you can ask me. So this video is there, you can refer it. Okay, and you can complete this up to this first milling operation, face milling operation, and for second we will send the next session. Any questions? First I will download the there any questions, or otherwise we will stop over here. I think I extended more, 1 minute, 1 hour and 7 minutes. No questions are there. Are there any questions? You can refer this video. I will upload the assignments, all second, third, and fourth also. You can complete that, and I will upload the video of that assembly also. Okay. Tomorrow I will upload that, but today I will assign you the 3 assignments. Okay, and due date for the assembly and one for the next Saturday, and this due date is after completion of this entire program. Okay, so thank you for this. I will stop the session now. Thank you.